Let's look at how to solve this problem. 5% sales tax is paid on taxable items. If you paid $1.75 in sales tax, how much money was the item you purchased? 5% is representing the part that is added on as tax. So it's based on a part of the total ticket price of whatever you bought or the multiple items total. It's a part of that. So in my notes over here, my work on the right-hand side, if you follow along with me, 5% sales tax is paid on taxable items. That's an important piece of information. You paid $1.75 in sales tax. It's the sales tax, not the item. When I build my line diagram, I start at 0%, draw my line to 100%, mark the things I know. 5% is a very small percentage. So when I put my Scoopy down for that, it's very small down here at the bottom, 5%, and I'm labeled it sales tax. And that's a portion, actually, we're not taking it off. It's going to end up getting added on to what you pay. But right now, all we're looking for is just what would the original amount of money be for the item. We can use the sales tax to get back to that 100%. So since the item price is missing, that's going to be an open spot here over the 100%. But we do know the sales tax. That is going to be the Scoopy across from the 5%. So we know the $1.75 and we know the 5% sales tax. It's the total we don't know. So in my examples today, you saw that this is a time we kind of have to work backwards. But if we build the statement and build our equation, we can solve for the total. I'm going to write my statement first. I've labeled on the left here, statement. 5% of some amount, I don't know what it is, equals $1.75. 5% is representing the $1.75. And it's 5% of what that will get me there. From that, I'm going to write an equation. I'm going to change my 5% to its multiplier form, 0.05. It's a single digit, so I need 0.05 to represent that 5/100ths. I don't know the total, so I'm going to write an X. This is using our algebra skills. But I do know that it's going to equal $1.75. 0.05x equals $1.75. Finally, let's solve to find the value of x. If I have this equation, I know whatever number of x's I have to divide by that. It'll make a giant 1. 0.05x, don't worry that it's a decimal. The strategy works the same because as soon as I write divided by 0.05, see how I have that giant 1? That's going to help me find what x is. I have to do that, though, on both sides of the equation. So 0.05 over 0.05 ends up being 1, a giant 1, x. So it's just x that's left on that side. On the right side, I have my $1.75, and I'm dividing by that multiplier like I did on the left side, dividing by 0.05. And when I divide that, it gives me a larger answer. It's telling me how many of those 0.05s fit into $1.75. It's like using the multiplier backwards with division. So we're going back to what that x would be. What would the total be? $35 is the total cost of that item that was purchased where the sales tax was $1.75. Because of using the line diagram with you as I started solving the problem, I did not go back and fill it in. But if I were you, now that you know this is $35, that comes back up here, and that is the 100%. $35 is the cost of the item.